Scientists are intrigued by one moon in our solar system, which has sparked the potential of extraterrestrial life among numerous celestial bodies. Welcome to Titan, the mysterious moon of Saturn that may hold the answers to some of the most significant questions regarding the possibility of life beyond Earth. As our knowledge of the cosmos increases, scientists are beginning to realize that life may not only exist on our planet. Titan has become a strong contender in our effort to explore far-off worlds in search of habitable habitats. Titan has drawn the interest of both astrobiologists and space enthusiasts due to its thick atmosphere, fascinating chemistry, and the possibility of liquid on its surface. Titan is the second largest moon in our solar system and is a cold and isolated world. Due to the dense orange haze that covers its surface, direct observations are difficult. However, in 2004, the Cassini-Huygens spacecraft arrived at Saturn and completely changed our perception of this strange moon. In 2005, the Huygens probe entered Titan's atmosphere, giving us a never-before-seen look at its enigmatic terrain.
Project Manager, Flight Director.
Go ahead.
Okay, we call loss of signal at 115546.
I hope you're all as deeply proud of this amazing accomplishment. Congratulations to you all. This has been an incredible mission, an incredible spacecraft. I'm going to call this the end of mission. Project Manager, off the net.
Titan is intriguing because it bears a striking resemblance to an early Earth. Its atmosphere is dense and mostly nitrogen-based, with small amounts of methane and other complex organic compounds. These organic substances have created the intriguing potential that Titan may support a distinct kind of life, particularly in light of the existence of lakes and rivers filled with liquid hydrocarbons.
A question that's been bugging us for a very long time. Are we alone? Is there any other life out there in the solar system except for planet Earth?
There's a lot of early Earth scientists out there who want to learn about, life. Is there life? Well, you can go to Titan as one possibility because it can be representative of what the early Earth was like before we were here.
According to scientific theory, life may have originated on Titan, where temperatures can drop as low as -290 degrees Fahrenheit, by using liquid methane as a solvent rather than water. This revolutionary idea suggests that life might adapt to and flourish in harsh conditions that are beyond our wildest dreams, challenging our conventional conception of habitability. Future expeditions and ongoing studies are intended to further explain Titan's secrets. The Dragonfly mission, set to launch in the next few years, will deploy a rotorcraft lander to investigate Titan's varied landscape, examine its chemical chemistry, and look for evidence of life in the past or present. The information gathered from this ambitious endeavor may offer novel perspectives on the possibility of extraterrestrial life. Titan encourages us to continue searching for answers by pushing the limits of our understanding and delving into the cosmic fabric as an indicator of the universe's limitless wonders. As we set out on this expedition to Titan in science, we are standing on the brink of discovery. Our curiosity grows, and our conception of what it means to be alive is challenged by the prospect of life existing on this distant moon. In 2009, NASA astrobiologist Andrew Poherl suggested that Titan, one of the known naturally occurring satellites in the solar system, may not support life due to the absence of liquid water on its surface. Water is considered crucial for life as it is the solvent used by all known organisms, and its unique chemical properties promote the self-organization of organic matter. Poherl also questioned the cost-effectiveness of exploring Titan for life as the likelihood of discovering it is uncertain. However, Titan's atmosphere is dense and contains organic chemicals, and it is possible that life's chemical precursors originated there. Hydrogen gas is also present in the atmosphere and could be used by methanogens or similar organisms to produce energy by mixing it with certain organic compounds. Although liquid water is the preferred solvent for all earthly organisms, life on Titan could use liquid hydrocarbons such as methane or ethane instead.
Astrobiologists since Carl Sagan have wondered if life might swim in Titan's hydrocarbon lakes. The chemical basis for such life would have to be entirely different from anything we know. All life on Earth depends on liquid water. Titan's surface has none of that. But we can imagine other kinds of life. There might be creatures that inhale hydrogen instead of oxygen and exhale methane instead of carbon dioxide. They might use acetylene instead of sugar as an energy source. How could we find out?
Some scientists believe that the rivers, oceans, and lakes of liquid methane and ethane on Titan's surface could harbor potential non-water-based life. These life forms would consume hydrogen instead of oxygen and react it with acetylene instead of glucose, emitting methane instead of carbon dioxide. However, the existence of such life is uncertain, and alternative hypotheses are plausible, such as weather phenomena or the presence of a mineral catalyst that permits a chemical reaction between acetylene and hydrogen. In 2010, Darrell Strobel from Johns Hopkins University presented evidence that supported the theory of methanogenic life on Titan. He analyzed observations of the concentration of hydrogen in the upper and lower atmosphere and found that hydrogen flows downward at a rate of about 1,025 molecules per second, which appears to stop near the surface. Another study revealed extremely low acetylene levels on Titan's surface, which Chris McKay also attributed to the existence of life. However, he warned that alternative hypotheses cannot be ruled out, and that the discovery of a mineral catalyst with an effectiveness of -178 degrees Celsius would be remarkable, though not as remarkable as finding an alien life form.
Every single cell is a muscle cell and a nerve cell.
All muscle, all brain. How smart is this thing?
NASA, the European Space Agency, and the Italian Space Agency collaborated on the Cassini-Huygens mission, which aimed to explore the Saturn system, with a particular focus on Titan, the planet's largest moon.
The beauty of Cassini is the design. It's the largest interplanetary spacecraft ever built. 12 different instruments brought from all over the United States and Europe. It's just a monumental machine.
3, 2, 1, and liftoff of the Cassini spacecraft on a 30-mile trek.
The project was named after two astronomers, Christian Huygens of the Netherlands and Giovanni Cassini of Italy, who made significant contributions to our understanding of Saturn and its moons. The Cassini spacecraft, which carried the Huygens probe, was launched on October 15, 1997, and took almost 7 years to reach Saturn, arriving on July 1, 2004.
9, 8, 7, 6, 5, 4, 3, 2, 1, and liftoff of the Cassini spacecraft on a billion-mile trek to Saturn.
The mission was equipped with an advanced array of instruments and tests to investigate the atmosphere, rings, and moons of the Saturn system. The Huygens probe, developed by the European Space Agency, was designed to penetrate Titan's atmosphere and land on its surface, providing the first direct and up-close measurements of the moon's surface. On December 25, 2004, the probe separated from the Cassini spacecraft and made its way towards Titan. On January 14, 2005, the Huygens probe successfully landed on Titan's surface after a parachute-assisted descent that lasted nearly 2.5 hours. During its fall and subsequent surface operations, the probe gathered and transmitted important information about the moon's atmosphere, weather, and surface features. The mission discovered that nitrogen makes up the majority of Titan's atmosphere, with traces of methane and other complex organic molecules. Titan's surface is largely shaped by its atmosphere, which is denser than Earth's. The Huygens probe also captured the first photographs of Titan's surface, revealing a diverse terrain consisting of mountains, rivers, lakes, and large dune fields. The evidence suggested the possibility of cryovolcanism or volcanic activity involving water or other volatile compounds. Cassini's findings confirmed the presence of lakes and seas filled with liquid ethane and methane on Titan's surface. These hydrocarbon entities have piqued interest in Earth's water cycle, as they mimic it along with the cycles of rainfall and evaporation. While the Cassini mission primarily focused on Titan, it also made significant discoveries about Enceladus, another of Saturn's moons. The presence of a subterranean ocean and evidence of geysers erupting from the moon's south pole suggested the possibility of hydrothermal activity and potential habitability. The Cassini-Huygens mission lasted more than 13 years, exceeding its originally scheduled 4-year duration.
I've worked on the Cassini project for almost 30 years, and that's an entire Saturn orbit. Part of Cassini's success is really the tremendous international collaboration.
We had 3 space agencies contributing to this: NASA from the United States, ESA, the European Space Agency, and Aerospatiale Italian, the Italian Space Agency, all contributing hardware to this mission.
On September 15, 2017, the spacecraft intentionally descended into Saturn's atmosphere to mark the end of its mission and avoid contaminating any of Saturn's potentially habitable moons. Titan is a moon that presents unique challenges to our understanding of habitability. Its environment is vastly different from what we typically associate with life, with extremely low temperatures, lakes of liquid methane, and a thick atmosphere full of complex chemicals. Some scientists speculate that if life exists on Titan, it may have evolved to use liquid methane as a solvent instead of water. This theory expands our understanding of the potential forms life could take, suggesting that creatures could exist that thrive in very cold environments and depend on unusual chemical processes. It pushes the limits of what we consider habitable and opens up exciting new possibilities for exploration. That's it for today's video. Thanks for watching. For more videos like this one, be sure to subscribe and hit the like button. We'd also love to know your thoughts in the comments below. We'll see you in the next video.